Okay, so part one. Here we have the most impressive one, I think. This is a little brass plate that I bent into the shape of the Radnor logo and just fixed it to brass tubing. This is not an EDM electrode. You'll see the hole is quite big. This is normal brass tubing. You obviously can use EDM electrode as well, but I got brass tubing for cheap, so I figured why not use it. And this is, I think, 8mm aluminum plate. You can see that it went in there quite a distance. I didn't want it obviously to go through, because then my little bib there and the top part of the R will just fall out. So that's one example of die sinker. If you squish it in, there's a little bit of corrosion there now because it stood for a while, and the water wasn't perfectly clean. So if you press it down, you'll actually see you need a good bit of force for it to come out. Next one is a flat, pretty much the same deal, same brass plate, it's just flat this time. And this one went in at an angle and another angle, so it's compound angle. And it came through really well. There's a slight curve in the cut, because there's a slight curve in the electrode. If you wanted a flat electrode, yeah, well, that wouldn't be great. But since I already had a curved electrode, it illustrates quite well how beautifully it makes a slot according to the electrode size. This little brass gear, also just ran it in for a little bit. Didn't want to run it straight through, because for illustration purposes this is actually a little bit better. So you can see it's got a flat bottom. It's got a little bip there, just because I had a little hole there. I did some flushing through the center of the core as well. Mixed results. Yes, it flushed a little bit better, but I got a little bit of pressure buildup. So the pressure tended to push the electrode away from the workpiece a little bit. So I struggled to control my spark gap. Eventually, just for simplicity's sake, I just flushed from the side. Gave me a little bit of a rougher finish, but came out pretty well. Then square holes, which is also just square brass tubing. This one I just did to depth to show you the little bit that stays on the inside. And up. This one is straight through. But with this one, obviously came the extra little piece that came out of the middle. So as soon as this electrode broke through, that just fell out. You got to fit in there like so, something like that. Yeah. And then you also have hardened materials. This is a little hardened ball bearing, obviously. Square hole did into there. Must have this one, I didn't run all the way through. I left a little piece and I just broke it out for a simple reason. I didn't want to run all the way into the bearing cage and destroy the bearing. So I just broke through just far enough so I can just tap for the last piece out. You can see there's a little spot there in the middle where the metal broke out. Obviously you could run straight through. For me it was just a little bit easier, and it had the advantage of, if I don't damage the bearing cage. I ran into one of the bearings, but it's still around. You can barely see it. Actually looking for the bearing right now. There we go, there's a little line on that bearing. I'm not sure if you can see it on camera. There's a little line there. I ran into that bearing, but it's still around, so the advantage is the bearing still works. Did pick up a little bit of gunk since I did this. And the last one, the advantage obviously with EDM is you can use any metal as long as it conducts. Doesn't matter how hard it is. To prove it does run into hardened metals as well. Here I have the hardened ball bearing, and no EDM video would be complete without someone destroying a file. So there's my little happy file. Okay, that's it for this review. Parts review, we'll do another one with the small hole parts, and maybe another one with rotor parts, because that's a topic completely on its own. Yep, thanks for watching.